Good morning friends. Today we are going to check what are the different basic operations can be done in Numpy array. Okay. For that I am going to write a code of this part for you. Import Numpy of NP. Sorry. Numpy of NP. Then writing just like array equals creating an array using NP variable. NP dot range of 0, 11. As you all know, it will create an array from the elements using 0 to 11. Okay, you check what is going to happen. Trying to print the contents of array. It is printing the values from 0 to 10, and the set value is 1 by default. But I am going to do is I am going to add array with the value array itself. Okay. Now I am going to check what is going to happen. Yeah, the value of arrays are doubled, just like this. Value of the array is added with the same value of the element. Okay. So each of the value can be doubled by using array plus array statement. In the same way, we can do other types of scalar operations, just like array minus array. It would subtract same elements from the same elements from next array, so that the result set would contain zeros. Okay, or all the elements are zeros. And if you are using same statement just like array into array, it would create the root of the each of the elements, because it is multiplied by the same element, so that it would generate the root of that square of that element. Okay. Now what we are going to do is we are going to take the do the scalar operations using this array. Means that suppose I want to add a significant constant number to each of these elements. What would I do? I have to add this 100 number to each of these elements in the array. If you want to do that, I have to give a command just like array plus 100, and I would like to check what is going to happen. This 100 is added to each of the element of the array, and the result set is generated just like this. Okay. Now I am going to check element is multiplied by a significant value, that is a constant value. Then what is going to happen? Yes, each of these elements are arrays elements are multiplied by 100. 1 into 100, 100, 2 into 100, 200, and 3 into 100, 300, and so on. Okay. Now I am going to check what is going to happen is I am giving a statement just like array by array. Okay. Then each of the element is divided by the same element. In this case, the first element is 0. So the 0 is divided by 0. What is going to happen? We will check what would be the result. Then array by 0. Yeah. Here the elements are displayed just like first one is none, then other all the elements are remains 1, because the number is divided by itself, so that the result set contains the 1 itself. Okay. But for the first element, it is of 0. The value of array is 0. So the division would be 0 by 0. It would generate an infinity in mathematics. Whereas in the case of Python, it would not cause for any type of error. Instead, it would just display just like none, N-A-N. That is the value of this value is not defined. That is the warning symbol, and it would not generate any type of error in the case of Python. Okay. And if I am going to do one other example, just like 1 by array. If I am going to check 1 by array. But in this case also, our first element is 0. So that when it is trying to divide 1 by 0, what is going to happen? We would check. A matrix is generated just like the first element is in of that means it is infinity, and all other generate some significant other types of values. Okay. Then the last value is 1, 0.1, and the other elements are the second value is 1, and the third value is 0.5, and so on. Okay. Then what was the command for that? It was 1 by array, that is 1 by element of array. Okay. Now I think that you got an idea how this can be done. and what values are generated if you are using these types of statements in the case of Python. cannot generate any type of error. If it causes an error, it would generate some types of other values like INF for infinity and NN for not defined and so on. Okay. Now I am going to give a command just like np.sqrt of array. Then I am trying to take the square root of each of the elements from the array. Okay. Matrix is formed just like square root of 0 is 0 and the square root of 1 is 1 and the square root of 2 is 1.414 and so on. Okay. The square root is generated as just like this. Okay. And if I am giving a statement just like np.exp exponent value of array, exponent value of array, what would generate? We will check what is going to happen here. Yeah, it will generate exponent value 1.00 e plus 00 and it is in the form of exponential. Okay. And a matrix is generated in accordance with the command. Okay. If I am going to give np.max of array, it would retain the maximum value of the array. Okay. You check, yeah, it is maximum value is 10 and all other values are lesser when compared to this 10. Okay. Now if I am giving just like np.log of array, then each of the values, log values for each of the elements of array is generated as a result. Okay. Yeah, it is generated just like first value is minus of infinity, that is log of 0, that is minus value, then the log 1 is 0, then log 2 is 0.69, log 3 is 1.0986 and so on. Okay. In this way we can generate different types of values, and these are all useful in the case of data science and data validation, data cleaning and so on. Okay. Now we would check what are the other operations we can be used using these types of Numpy array. And the next library we have to cover here is that of pandas. Pandas are a very important one when compared to this Numpy array. Numpy and pandas are different types of numerical matrix operations which are very vital in the case of data science. Okay. We will come to with a new video how these pandas are useful in data science.